Contestants, as always, the contest comes to you in 5 rounds. The first round is a round for fundamental concepts. I'm going to be presenting you with simple and direct questions. I'm expecting simple and direct answers from you. If you answer your major question correctly, 3 points. If the question is incorrectly answered, it becomes available to the 2 remaining schools. A school may ring and attempt an answer. If right, 1 bonus point. If not, there is a penalty, 1 point. For questions which require calculations, you have 30 seconds in which to present your answer. If there are no calculations involved, you have 10 seconds to do so. Gentlemen, all of the questions are to be attempted once only. Best wishes to all 3 schools. I'll be starting with you, Tamale Senior High School. But before I come to you, this first set of questions will require 10 seconds of your time, and I have a preamble to all schools. Please pay attention to your preamble. The extraction of metals from their ores involves various processes depending on the properties of the metal and the ore. Name the most common method of extraction of the given metal from its ore. The keywords were most common. All right, please, did you hear the preamble, or would you like to hear it again? One more time. The extraction of metals from their ores involves various processes depending on the properties of the metal and the ore. You are to name the most common method of extraction of the given metal from its ore. So, Tamale, your metal is potassium. Review.
We have reduction.
That's incorrect. Yes, St. John's Selassie.
Electrolysis. Electrolysis.
You're right. With the same preamble, Accra Academy, copper. Yes, Abdul Wahab.
So, by reduction.
That's incorrect for bonus. Okay. The right answer is smelting. Smelting. All right. With the same preamble, St. John's. Gold. Yes, Selassie?
Cyanidation.
You are right. Considering all the trouble we are having with Galamsey and so on, I think I need to make a point about this. Yes, cyanidation is the most common and is the method that is normally to be used. But here in Ghana, sometimes people have been using amalgamation, right? This is a historical method. It has serious environmental hazards, and we really should not be doing it. I hope that point is clear. All right, so cyanidation. All right, next set, 10 seconds with a preamble to all schools. Preamble. Name the type of tongue papilla to which the given description refers. So what this means is when I get to you, I will describe something to you. You are to name the type of tongue papilla to which your description refers. I hope it's clear. All right, so Tamale, when sectioned, they resemble mushrooms and are present mostly at the apex or tip of the tongue. Yes, Mohammed?
Foliate papillae.
That's incorrect for bonus. All right, I'll hold on for now. With the same preamble, Accra Academy, they are thin, long, mechanical papillae that are not involved in gestation but are the most numerous. Yes, Ampofo.
Gustatory. So we have gustatory papillae.
That's incorrect for bonus. All right, I'm holding on. And then with the same preamble, St. John's School, there are small folds located bilaterally on the posterolateral sides of the tongue and are richly covered with taste buds. For bonus. Oh dear. Gentlemen, you don't like the papillae, yeah? All right. So Tamale, yours was fungiform papillae. Accra Academy, yours were filiform papillae. And St. John's, yours were the foliate papillae. Next set, 30 seconds. And Tamale. Find the limiting angle of resolution for a single slit of width 0.50 millimeter at a wavelength of 650 nanometers. Yes, Rabiu?
We have 30 degrees.
I'm not accepting it for bonus. All right. It's 1.3 milliradians. Accra Academy, find the wavelength at which the limiting angle of resolution for a single slit of width 0.40 millimeter is 1.4 times 10 raised to the power negative 3 radians. Ampofo.
So the wavelength is 5.6 by 10 raised to the power negative 6 meters.
That's incorrect for bonus. Yes, which of you? Rabiu?
5.6 by 10 to the power negative 7 meters.
That's right. St. John's School, find the width of a single slit, which gives a limiting angle of resolution of 1.5 times 10 raised to the power negative 3 radians at a wavelength of 720 nanometers. Yes, Prince.
4.8 times 10 to the power negative 4 meters.
You're right. All right, for the next set, you have 30 seconds once again, and I have a preamble to all schools, a short one. Your preamble is, solve the absolute value equation. I hope you got it. All right, so Tamale, absolute value of the expression x squared minus 2 is equal to x. Yes, Mohammed. No, Rabiu.
So we have x is equal to plus or minus 1, or x is equal to plus or minus 2.
2 out of 3. You provided some wrong answers, so I will come back to you with the right answer. Okay, Accra Academy, with the same preamble, absolute value of the expression x squared minus 12 is equal to x. Yes, Ampofo.
X is equal to 3, or x is equal to 4. X is equal to 3, or x is equal to 4.
You are right. St. John's School with the same preamble. Absolute value of the expression x squared minus 20 is equal to x. Yes, Alasi?
X equals 5 or x equals 4.
You are right. Okay, so Tamale, you have figured out your problem, right? Yes, it doesn't make sense to have the negative value. So I penalize for giving me negative answers. So it's a positive 1 or 2. All right, next set. You have 30 seconds, and there's a preamble once again. Preamble to all schools. Give the IUPAC, or systematic name, of the major product formed from the reaction of the given carboxylic acid with ammonia or amine. Did you get the preamble, or you like to hear it one more time? Okay, so give the IUPAC, or systematic name, of the major product formed from the reaction of the given carboxylic acid with ammonia or amine. That's a preamble. So yours, Tamale, benzoic acid and ammonia. Did they make it? No, for bonus. You rang? Okay, go ahead.
Benzanamide.
I'm not accepting it for a bonus. The right name is benzamide, or benzene carboxamide. That's the other name for it. Okay. So, Accra Academy, with the same preamble. Butanoic acid and methylamine. Yes, Abdul Wahab.
Butanamide. So, butanamide and methanol.
That's incorrect for a bonus. All right, I'm hanging on to your answer. I'll come back to you. With the same preamble, St. John's School. Pentanoic acid and ethylamine. No, for a bonus. All right. So, Accra Academy, yours was N-methylbutanamide. And then for you, St. John's, you had N-ethylpentanamide. All right. Next set, 10 seconds. Tamale, What does the volume of blood that is pumped out by the left ventricle of the heart into the aorta in 1 minute refer to? Yes, Rabiu?
Cardiac output.
You are right. Accra Academy, how is cardiac output calculated? Yes, Sampofo.
So the cardiac output is calculated as the product of the rate of heartbeat times the stroke volume.
You are right. St. John's School, what happens to the ventricles of humans during ventricular systole of the cardiac cycle? Yes, Prince.
They contract to pump out blood. So their walls will contract in order to pump blood.
That's right. For the next set, you have 30 seconds. Tamale, find the tensile load that stretches a 1.50 meter steel wire by 0.250 millimeter if the cross-sectional area of the wire is 0.450 millimeter squared, and Young's modulus of the steel is 215 gigapascal. Yes, Rabiu?
So the tensile load is given by 12, that's 18.8 Newton.
That's incorrect for bonus. Which of you, Accra Academy? Yes, Sampofo.
We have 3.03 by 10 raised to the power 4 newtons.
No. The right answer is 16.1 Newton. 16.1 Newton. All right, your own question, your major question, Accra Academy. Young's modulus for yellow brass is 105 gigapascal. Find the length of a yellow brass rod of cross-sectional area 0.500 millimeter squared that extends by 0.150 millimeter when stretched by a 2.10 Newton tensile load. Yes, Abdul Wahab.
Find the length. The length is 3.75 meters.
Yes. St. John's School, find the cross-sectional area of a 2.50 meter thin bronze wire that stretches by 0.240 millimeter when stretched by a 4,750 Newton tensile load if Young's modulus of the bronze is 95.0 gigapascal. Yes, Prince.
It is equal to 5.22 by 10 to the power negative 1 millimeter squared.
No, for bonus. The right answer is 0.521 millimeter squared, or 5.21 times 10 to the power negative 7 meter squared. Next set, 30 seconds. Actually, I have a preamble to all schools before I come to you, Tamale. Preamble. In the coordinate plane, the point A is reflected in a line L to the point B. Find the equation of L given, that's a preamble, one more time. In the coordinate plane, the point A is reflected in a line L to the point B. Find the equation of L given. All right, so now Tamale. A has coordinates -3, 5, and B has coordinates 5, -3. Yes, Rabiu?
So we have y is equal to x.
You're right. With the same preamble, Accra Academy, A has coordinates 4, 3, and B has coordinates -4, -3. Yes, Ampofo.
So the equation is y is equal to x over 4.
That's incorrect. For a bonus? Y is equal to -4x over 3. All right. With the same preamble, St. John's School, A has coordinates 3, 6, and B has coordinates -6, 3. Yes, Prince.
We have 2y is equal to 6x. 6x.
That's incorrect. For a bonus. The right answer is y is equal to -3x. Okay, so you then simplify and the negative was also not there. All right. Next set of questions, 30 seconds. Tamale, a sample of barium chloride is dissolved in water at 20 degrees Celsius until the solution is saturated. Given that the solubility product constant of barium chloride at this temperature is 4.0 times 10 raised to the power negative 12. What is the concentration of chloride ions in the resultant saturated solution? Yes, Mohammed.
2.0 by 10 to the power negative 4 mole per dm cube.
You are right. Accra Academy. When 0.20 gram of calcium fluoride is stirred in water at room temperature, the concentration of fluoride ions in the solution is found to be 4.0 times 10 raised to the power negative 4 mole per decimeter cubed. Calculate the solubility product of the salt at this temperature. Abdul Wahab.
3.2 by 10 raised to the power negative 12.
That's incorrect. Go ahead.
3.2 times 10 to the power negative 11.
I'm not accepting it. Right answer, 3.2 times 10 raised to the power negative 11 mole per decimeter cubed. All right. Your own question, St. John's. At a given temperature, the pH of a saturated solution of aluminum hydroxide is 9.0. Determine the molar solubility of aluminum hydroxide at this temperature.